Okay, so for this afternoon, this will be our topic, power MOSFETs and IGBTs. Now, before anything else, may gamay lang idea. The same with power BJTs. Ang behavior, capabilities, and characteristics sa ordinary MOSFETs o power MOSFETs kay almost the same good gapon. And the same sa power BJT, mas dako lang iyang ratings or capacity. Mas na siya greater capacity for current, power, of course, voltage. So, compare lugar, excuse me sa posa. Oops, sorry for that. Again, from the top. Again, the same with regular MOSFETs. Pareha ang characteristics of behavior operations sa power MOSFET. But unlike sa atong discussion last week power BJTs, almost the same na gyud, no? Almost the same na ang pag-handle sa power MOSFET. Unlike sa power BJT, right? If you could remember, na ay gamay nga or na additional, no? Na mga additional na requirements sa pag-handle sa power BJT compared sa regular BJT. One of it is dapat na siya ay driver circuit, no? Driver circuit. And if you could also remember, ang atong power BJT is na ay quasi saturation, no? Kaning area before sa ay in between sa active sa saturation. So nagi differences ang power BJT and regular BJT. Okay, aside sa mas dako og power rating ang power BJT. Whereas ang MOSFET, power MOSFET I mean, almost identical na gyud, no? Almost identical. And we've also remembered na mas forte, no? Mas forte ra ba ni sa or mas pabor, no, ang power MOSFET when it comes to switching compared to BJT. So MOSFETs use only majority carriers in conduction, and it is commanded by voltage signal instead of current as compared to BJT. So if you could remember, we sometimes term the MOSFET as a voltage-controlled current source. So naman siguro equivalent circuit niya later or model na here. Let's use this one as our example. Apply tawag voltage dire sa gate terminal. Apply tawag voltage here. So that current will flow from the drain to the source. Okay. So that's one of the main differences between the BJT, whether power or not, or regular BJT and the MOSFET. And it uses only majority carriers in conduction. So unlike the BJT na PNP or NPN, as for the MOSFET, you have only two types, N-channel MOSFET and P-channel. Naka-state ba dire? So mostly used ang N-channel, no? Because ang majority carrier sa N-channel are electrons as compared to holes for P-channel. So mas paspas daw, no, ang current flow if electrons ang majority carrier. And is commanded by voltage signals and current. Additionally, the manner of how electric terminals are constructed present a great advancement in producing high-speed transistors. Actually, power MOSFETs can switch.
Sir.
Yes, and
Nakay-gina-share, sir?
ay, di makita.
Dili, sir.
Wala di ay. Wait lang ha. Nakabutang biya. Share screen ay. Ano man eh? Ganyan pa dito ba? Weird. Nagod ni siya nga kaning boto, kaning indicator sa top right kanang pula nagod na kanina. Don't know. So anyway, sige kani. Moment ito kung i-share suppose we ganina nga screen. Actually, power MOSFETs can switch at around 1000 megahertz. 1 megahertz, I mean. All these features resulted in a different physical behavior of MOSFET compared to BJT. And practically speaking, it's easier to handle MOSFETs compared to BJT, no? Samot na kung power BJT ang concern. Ito palang fact na we need a special type of driver circuit to drive the base of the BJT. Kana alone, no? Maka lesson na sa complexity sa pag-handle sa MOSFET. It's because ang BJT, as you could remember, a BJT is a current-controlled current source. Whereas the MOSFET is a voltage-controlled current source. So we only need voltage level to drive or to trigger our MOSFET. Okay? So these are some actual examples of MOSFETs. Naka-IC nga package. This one is a special type of MOSFET, specially built for automotive applications. And this is the schematic diagram, schematic symbol of the MOSFET. Sa CMOS, atong ginagamit, MOSFET mangyapon ng CMOS, atong ginagamit kay, ayan naman to, di ba? Dapat nta, kung panggid ta, kung putigid ta, no? Yan na ta to. No? Pwede naman na i-shortcut as kuan, kato atong the usual way pag-draw, no? Sa MOSFET. Pwede rin nga na. NMOS. PMOS. Okay? So this is the basic structure of a vertical MOSFET. No? Isa ito sa image on the left. So these are its terminals, the source, the gate, and the drain. Okay. So yung symbol. Yan na. So we have the gate, the drain, and the source. Conventional current flow. Current will flow from the drain to the source. So the difference also of a MOSFET to that of a BJT is ang gate na terminal is naka-insulate or not directly connected to the layers, no, or to the semiconductor material due to this one, the silicon oxide na layer. So this insulates or separates the gate from the semiconductor material. So, one yung reason na we only need a voltage source. No, mag-apply lang ng voltage source sa gate to the source. So, naka-illustrate na sa PCAS image. So, erase na ako dire. So, nagya po yung mga, although this is specifically an N-channel E-type MOSFET. E means enhancement, right? So this is an N-channel E-type MOSFET. Nagya po yung P layer. No, nagya po N layer. Well, that facilitates, of course, the flow of majority carriers. Here, sa kanina image, if voltage is applied to the gate and source terminals, VGS, this one, voltage lang i-apply, not daily current, charge will build up sa gate na terminal. These positive charges that will build up. Positive, nakakonect man as positive terminal. So, mag-build up dire ang positive charges. So, what will happen if positive ang mag-build up diha? So, it attracts negative polarity particles. In this case, electrons. It will attract electrons from the N-type semiconductor material. So, ang ilang mga N-type, ang N-type, ilang mga electrons is i-attract, no? I-attract ni gate. Batungod kay na ay silicon oxide, of course, is nakalahos, no? Insulator man eh. Ang silicon oxide is an insulator. So, dili makalahos ang kuan. Ang mga electrons, ang mga majority carriers sa N-type semiconductor. So, what will happen is magpundo lang sila diya, no? They will just stay here. No? Mag-form na sila dire o marag channel. Okay? Nga this now connects these N-type semiconductors to this N-type semiconductor. So, mga-create og isa ka N-channel. No? That's why N-channel MOSFET ang tawag. So, this is the N-channel now. Which will now facilitate the flow of current from the source to the drain. Going here. Yeah. Okay. So, yan lang, no? It's as easy as that. We just apply voltage to the gate to the source terminals and current will now flow. Yan na lang. No? So, here now is the characteristic curve of our MOSFET. We also have three regions. We have the ohmic region, the active region, and the cutoff region. Ang ohmic region here is synonymous to the saturation region of the BJT. But medyo trivial na ang reason nga nung wala sila nagamit og saturation for the ohmic region. Technically, ang saturation region daw sa MOSFET is ang active region, no? Active or saturation. Pero most probably that would cause confusion. So, wala nila na gilabel sa yana. And gilabel na sa ohmic region ang quote-unquote saturation region sa MOSFET. Ohmic siya because somehow na ma-measure na resistance across the drain to the source terminals when current will flow. No? I-constant na resistance. That's why ohmic ang tawag. No? Ohmic or linear region. So that's masyag resistor, di ba? Ang graph sa resistor is straight line. So if we want to use the MOSFET as a switch, the same gapon. Mag-change og state from ohmic to cutoff and cutoff to ohmic region. And as an amplifier sa active region, for which we know, dili kaayo best suited ang MOSFET for amplification. No? So mato topic na to before sa LX2. And this now is the relationship between VGS and VDS. Okay, VGS and ID, I mean, VGS and ID. We know that ID, the current flowing across the drain to the source current, drain to the source terminal, mamuning ID, di ba? Flow from the drain to the source. That is dependent sa applied voltage between the gate and the source. Okay, so this is the relationship, or we could somehow state it as a transfer function between the VGS and ID. So dependent si ID kay VGS. So masyag diode, no? In this respect. So how do we know if ang atong MOSFET or ang atong device, technically the MOSFET, is operating which region, no? Which is it operating? So naman tayo tulo, ohmic, cutoff, and active. For the ohmic region, it is when VDS, the voltage across drain and source, is less than VGS minus VTH. VTH is the threshold voltage needed by the VGS to start conducting. No? Kung sa kuan pa kung sa BJT mo na 0.7. No? So sa FET or MOSFET, dili na siya exactly 0.7. It's much lower than that. And sa atong analysis sa CMOS, we model it as 0. No? 0 ang VTH. But we know that the MOSFET is in the ohmic region again if VDS is still less than VGS and VTH, where VGS is greater than VTH. It is in cutoff. We know cutoff is an off state if VDS is greater than 0, but VGS is less than VTH. So wala na wala na satisfy ang VTH na requirement. No? So later siguro ato ning i-tagsaon og example. No? And it is in the ohmic region, active region, I mean, if VDS is greater than VGS minus VTH and VGS is greater than VTH. So sa ohmic region siya, remember before, no, sa itong pag-analyze ito sa CMOS, kasi CMOS is a MOSFET mangyapon. Lagay ito pang model, nagputang mo ng tag 1010, 1, then dili atong VDD. Naman to, di ba? So, ato lang i-specify gamay. Ang source diha, ang VDD dili. Kung yan lang siya, VDD is equal to VDS, or VDS is equal to VDD if mag-conduct siya. So it's operating in the ohmic region if VDS, voltage here, across the terminals, is less than VGS minus VTH. No? So ohmic siya. Or kung sa BJT siya masyag nakasaturate na on kibali ang atong MOSFET is if nasa ohmic region. No? On, then off. VGS is greater than VDS. And VGS is greater than VPH, of course. Cut off kung bali, VDS is greater than 0. And VGS is less than VTH. No? So ato lang upload naman kita before, no? So operation sa MOSFET, itong nagatuon taog CMOS. Pero dire, at least makita nato mas detailed lang, no? Mas detailed lang na explanation sa operation sa MOSFET. Kung naman to subay-subay, di ba? Ato na ning kung magamit ko tag term gikan sa pikas nga subject. Gitabunan na nato ni og abstraction kani nga detail, no? Wala na ta nag-deal with mathematical equations but lang ta. Subay og mga ones and zeros. No? Kung 1 pod si VDS, ayun na bitaw. So, nisaka to abstraction sa ito pag-learn na to before sa CMOS. So, gusto ta maka-learn sa actual or in the device or transistor level, mo ni siya, no? Mo ni nga mga formulas ang na-describe sa itong MOSFET. So, yan na lang. If you already know how MOS operates, mo lang na siya ang meaning aning mga equations, no? Okay? So, these are the MOSFET equivalent circuits that we could use if ang application na to is in power electronics. Diba? Okay. So, di nato makita that this current source, the current flowing from drain to source is a function of likot lang inyong ulo, no? Is a function of K, of VGS, and VTH. Okay, so it's dependent sa kaning mga voltage sources, particularly VGS. Okay, the value of VGS is i-compare mo nato na siya sa value ni VTH. Pero ahead man gid mag-flow ang current from drain to source if na voltage sa gate og source. So again, this equivalent circuit illustrates as the MOSFET as a voltage-controlled current source. And notice na yung mga capacitances, no? Na mga capacitor. But then again, equivalent circuit na siya, no? Malagihang actual na behavior. Kung mag-measure ta og capacitance sa iyang mga terminals, na ay ma-measure nga capacitances. That's why ang actual na equivalent circuit of a MOSFET is na ay capacitance. Hindi pwede nga ignore na siya. If I remember correctly before, kang Boylestad, nga nila to iyahang model na wala niya gi-take into account ang capacitances. Muna ang G. Muna ang S, muna ang G. So, mas realistic ang model if atong ina-consider nga na ay capacitances across the terminals. Even ang even ang BJT, the same magyapon. Basta na yung mga terminals, most probably, na agad na yung mga stray or parasitic na capacitances. So this is the equivalent circuit for the ohmic region. Remember, na ay somehow small valued resistance across the drain and the source when it's operating in the ohmic region. So remember again, ohmic region is the saturation region for BJT. So when current is conducting across the drain to the source, we expect na it will be impeded by this resistance. Okay. Okay, next slide, honey. So before that, how do we solve for ID? Again, depende sa, just like before, how do we know if what region is, or yeah, what region is the MOSFET operating currently? So we use these equations. The next question, what is the amount of current flowing across the MOSFET? So depende sa region, no? Depende kung unsa siyang region currently. So ako lang sa siguro dire ang different regions again. The ohmic region, the active region, and the cutoff region. For the ohmic region, ID is equal to K times 2 VGS minus VTH times VDS minus VDS squared. As for the active region, ID is equal to K VGS minus VTH squared. And of course, kung cut off, ID is equal to 0. If gamito na ito nga mga relationships, itong equations previous slide, it could come up that VDS is equal to VGS minus VTH. You substitute this one to both equations sa ohmic and sa active region, VGS minus VTH as VDS. Kasi both sa active and sa ohmic region, we use this formula, VDS is equal to VGS minus VTH. That would make ID, both for active and ohmic region, ID is equal to K VDS squared. Yan na lang. So ID now is purely, we have an equation that shows us ID is purely dependent on VGS. K is a constant of proportionality, which could be found sa mga data sheet, dependent sa pag-manufacture or sa nga part number na siya ng MOSFET. But dire, VGS dapat ni. Okay? VDS lagi. So ID is a function of VDS. So dependent siya sa value sa VDS. Okay? So lang, no? So this circuit will be used now to analyze the turn-on and turn-off characteristics of a MOSFET. No? So dili siya equivalent circuit, but somehow we could call this one as a test circuit. Meaning, insert na to doing atong device, atong kani, and you make measurements. In this particular case, timing measurements or timing analysis. So sa VGS, natay gi-apply nga voltage from VG. Na-connect sa load nga part is an inductive load, and natay diode. Again, we call this diode sa ingani nga orientation siya gi-connect. We call this as our snubber diode. Snubber diode. This allows current to flow in our tank circuit even if wala na current mag-flow particularly sa hole, the circuit as a whole. So, magtuyok-tuyok ko din ang current. No? Magtuyok-tuyok siya or diha mag-flow atong current because of the diode. But balik ta dire again. Atong i-connect sa VGS is a VG, voltage source sa gate to source terminal. So during turn on, this is its waveform during the turn on process. So we have 4 waves. We have VGS, we have VG, VGS, ID, and VDS. And we have also 4 phases. T1, T2, T3, T4. So, maybe ato siya ni itag sa tagsaon, no? Again, dili nagiging siya lisod subton because if you remember, yan igapon tong uban, no? Ang diode ug ang BJT. Yan igapon to sila. Meaning, before anything else, or shortcut lang ni siya, no? T4 is when our transistor is on. No? How do we know? VDS is 0. No, VDS is 0. And ID is high. Bali siya sa T1. No? ID is 0 and VDS is high or equal to VCC pa. So again, because of these non-instantaneous delays, muna yung cause ng maning reason why our power transistors or power electronic devices consume power because of the length sa time delay. So, what is T1? No? How do we so ang T1 or ang first phase? T1 is when, or T1 ends when VTH is reached. Dala. When VTH is reached, the voltage level required for current to conduct across the VDS terminals dapat ma-satisfy sa ang value sa voltage sa VGS, which is equal to this one, no? VTH. So, walang T1. T1 ends when VTH is reached. Na-reach na yung VTH. So, once VTH is reached, T2 na dayon. So, saan T2? Sa ihang characteristic. During T2, nag-start na conduct ang atong ID. No? So, ID naman ang na-change. So, ako yun So, muna yung focus sa T1. Nag-end ng T1 the moment na-reach ang VTH. Si T2, that's the time that the current IDS is climbing to a specific level. Here. T3 is when VDS starts to drop to 0. Starts pa lang, no? So, magsugod ang T3, pagsugod po sa pag-drop ni VDS towards 0. So, pagsugod ng drop sa kay VDS to 0, Si ID is nag-constant na. Constant na siya. And T4 starts automatically pag abot gyud og 0 ni VDS. No? So I think it's easy to visualize man. Kato atong equivalent circuit, no, not equivalent circuit. Atong test circuit earlier, this one. So for each transition or for each phase, nas lahi nga equivalent circuit. So at interval T1, so ito atong pag ginatimanan sa T1, wala pa na abot ni VTH wala pa abot ni VGS si VTH. So si T1 it's acts as if malaging ani, no? Wala pa man na-reach ang VTH. So wala pa atong current source here. So empty pa. Kay kay T2, no? Sa second phase, si ID is ka-increase to a constant na level. So, dalang T2. ID is increasing. Although day. Yeah.
Hello? Yes, sir. Sige, sir. Makasulog naman
Sa
sir, no?
T3, so ito atong sa T3. Sa T3 is pagsugod og drop ni VDS. So, pagsugod og drop ni VDS, ma-reverse bias si diode. So, nanay current mag-flow from the source to the loads. And na-complete na dayon pag abot sa phase 4. Current will flow freely here. And ang atong MOSFET is na model na as resistor. Okay? So, wala lang meaning aning nga mga tagsa-tagsa nga equivalent circuit. This is what happens internally sa atong MOSFET. When ang mga transitions ay gakaitabo. No? This one. And again, this timing diagram is pareha naman sa other electronic devices like PJT and diode. Kung atong doing ng power consumption, again, power consumption is always when ang power consumption is ang product sa current o voltage. So, 0 siya when, of course, one of VGS or, in this case, ID, one of either ID or VDS is 0. So, this is fully on, T4 I mean. Sa T4, fully on si ID, fully off si VDS. So, 0 ang power consumption diha. No? 1 times 0 is 0. Sa T1, 0 man si ID. 0 pa si ID. So, assume nga gikan na siya og rest siguro kay 0 man yung ID. So, the same gapon, 0 minus maximum, still 0. So, wala pa power dissipation here. Power is dissipated in these transitions or these states or phases in T2 and T3. Kung multiply na to ni, nga na ito makuha. Estimate lang niya kung linya po. Sure ko, yan, nagigapon na siya. And during T3, yan nagapon. I-multiply this one with that one. So, yan nagapon. So, ano yung power dissipation of our semiconductor device. And we don't want this to happen, or if di matagan na ato ipalesen, so dapat mas gamay, no? Ang kaninga mga transitions. Mas nipis, kibali. So this is for the turn on. Again, even if wala tanaw sa mga equivalent circuit like this one, equivalent nga test circuit, if kanila atong tanawon, dali na ito mas dali na ito masabtan ang characteristic sa atong MOSFET. So the same gyapon sa turn off. Turn off na characteristic. No? During turn off, ID will drop to 0. And VDS will come back to its original nga voltage value, which is, in this case, equal to VCC. So, opposite lang sila sa turn off. Of course, dapat lang. And almost the same na gyapon siya sa other
July 5, no? July 5.
Yeah, the same na gyapon siya sa other nga devices. No? So, pwede na gyapon ta mo balik atong usual nga analysis yun, guys. Katong ing ana. No? Noon, CMOS man eh. And kung yung tag CMOS, nagyod na PMOS o NMOS. Pero, pwede na mo kuhag isa. No? Kuha tag isa ana. NMOS lang. Kung na voltage dire, may current po flow. Kung wala voltage, wala current po flow. Yan na lang, no? Simple lagi kaayo ang MOSFET. That's why ato lang nang gina-substitute as kung one. So to. So, substitute na siya nga kung 1 eh. 1 po dire. Kung 0 dire, 0 dire. Nganong 0 man, if 0 dire, yeah, of course, 0 na siya dire. Kaya off man ang atong MOSFET. So if off si MOSFET, wala current po flow. Sakto. Pamaday ni, no? Enhancement na N-channel. So remember lang, ang pinaka-convenient na NMOS, pinaka-convenient nga MOSFET nga gamiton is the N-channel MOSFET. NMOS, nilay. N-channel MOSFET nga enhancement type. Enchanted na ni. Enhancement. E-type nga N-MOSFET. Moning pinaka-convenient o pinaka-ideal nga transistor. Moning nga klase nga MOSFET ang pwede lang nato ma-model as mag-logic na 1-1 or 0-0. So, kaning operation, coupled with the fact na kinanglan nato o MOSFET nga gamay og transition time, no? So kana lang alone is enough for us to understand MOSFETs. So this is an application of one particular application of MOSFET. So man nasya sa from AC to a conversion, no? Cyclo conversion on the AC to AC mga gyapon ni sila. AC to AC. AC to AC. Then AC to DC. So itong tawag sa AC to DC, rectifier, power supply. Rectifier, diba? Rectifier, diode. So itong term, guys, kadumdum mo. AC to DC. Tapos yung mag sa exam. Inversion man ang kuan, DC to AC. Inverter.
Rectification, sir. Oh, char.
Rectification na to? Nalibog na naman ko.
What, sir? Nalimot ko.
Limot na. May tato tong previous be. Ano ba to dire? Power diode. Magwa na to na load dire. Wait, previous ko again. Basta kaning AC to AC, mo ning cycloconversion, no? Convert lang niya from one level to another. Whereas AC to DC is, lagi mo rectification siya ito. Limot noon ko. Kaya, basta, again, may kita ba? Yeah, electric vehicle. No? So, automotive ang application dire. No? Sa kalinga kuan. Mga hybrid siguro ni or electric vehicles, no? So much for MOSFETs. I hope nasabtan na ito na yun, no? Technically, ako lang gi-explain ang atong ginabuhat previously nga kaning 11 o 00 na ako lang mo na itong shorthand na to. Pero mo dapat ni nga mga equations. Duha mode na state code on off mga good pug logic gate. So that's why we did not anymore deal with these equations and nagdirect sa atong digital nga abstraction kana na lang. So this one, no? This concept together with the idea that ang power MOSFET kay na mga nag-involve og delay. Mo na siya, no? Mo na siya ang characteristics and behaviors of MOSFETs. So kato lang, okay? So move ta sa next na power electronic device, the IGBT or insulated gate bipolar transistor. This is what I've said before, na ang IGBT is somehow halfway between the BJT and the MOSFET. No? And tungkol siguro mapud lang gigamit nga schematic diagram or schematic symbol for the IGBT, no? Partly MOSFET, partly BJT. Ang iya po mga terminals, you notice also nga gihulam niya sa both nga transistors na kung asa mag-flow ang current from collector to emitter, no? Marag BJT. Pero ang i-apply nga voltage is voltage ang i-apply okay? The same siya sa MOSFET in a sense na voltage ang i-apply, but the same siya sa ako lang i-summarize. The same siya sa MOSFET. Di lang tungkol sa logo, ha. The same siya sa MOSFET because voltage controlled device siya. But the same siya sa BJT and in that it is bipolar. No? Bipolar iyang kuan. Meaning, ang flow sa carriers is na ay N and P. No? Na ay electrons and holes na flow. Unlike sa MOSFET nga, electron flow lang yun. Okay? Na ay both electron flow and hole na flow. Busa bitaw bipolar ang gitawag. Mao man po nang reason nga nung bipolar ang BJT. No? Na ay electron flow and hole flow. Unlike sa MOSFET nga, electron flow only. So Marsh best of both worlds, no? Best of both devices. So if we apply a voltage sa gate to emitter, GE, current will flow from collector to emitter. So if we understand that, particularly we understand or ano lang, if we understand how BJTs and MOSFETs work, basically we also understand how IGBTs work naman. Kaya yan agad na siya, no? Kung gusto lang tamo go deeper, no, pwede man tamo analyze sa iyahang structure. Ma-observe lagi po nato dito sa atong kuan, no, sa atong balaan before sa BJT and sa MOSFET. It is like the MOSFET again in a sense na insulated gihapon ang gate from the semiconductor device, semiconductor material, no? Na gihapoy silicon oxide that separates the gate from the semiconductor material, no? So that's why insulated gate ang tawag kay insulated gihapon. No, malagi siya insulated nga BJT. Yeah, partly MOSFET, partly BJT ra gyud. So if ma-apply og voltage sa gate og sa emitter, no? If we apply a voltage drop or voltage source sa gate ug sa emitter, current will flow from malagyapon siya og BJT, no? Current will flow from the collector to the emitter. Yan na. P and P. So it's accurate to say partly BJT, partly MOSFET siya. The IGBT is a device that integrates the advantage of having low on voltage from BJT with the advantage of having an insulated gate input from MOSFET. Okay, sa BJT, VBE, diba, is equal to 0.7. So the same gyapon dire, low iyahang threshold voltage. Unlike sa FET, no? Mas dako-dako gyud compared sa BJT. Such integration makes the IGBT a device with some superior characteristics compared with BJT or MOSFET. With relative high switching speed pod, the same as MOSFET. An IGBT can be gated, like a MOSFET, and the output current is handled in a manner similar to BJT. IGBTs do not have the body diode found in MOSFET, thus an external fast recovery diode is usually mounted in the same package for holding high reverse voltage. So, kinahanglan gyapon siya og snubber diode sa collector to emitter terminal for fast for holding high reverse voltages. Yeah. Kay partly BJT man siya. So man ang characteristic curve almost the same gid gyapon sa BJT, but if you remember before sa BJT, yan na, each of these curves represent different IBs, IB4, IB3, IB2, and IB1, no? Mga currents, mga controlling current towards the base, no? Kani is voltage, VGE. No? So each of the curves represent a particular voltage drop. So pareha siya sa BJT in a sense nga kada isa ani is the controlling variable. So dili siya the same sa MOSFET. Dili siya the same sa MOSFET na ohmic region. No? So partly gapon, no? Partly again, even sa characteristic curve we could observe nga partly BJT, partly kuan siya, partly MOSFET. Even yung switching, di na necessarily nga mo go pag deeper kay mga ikaapat na siguro na nga switching characteristic nga pareha ra gid sila tanan, no? Pareha ra ang switching characteristic sa diode, sa BJT ug sa MOSFET ug para sa IGBT. Nasubay naman nato. Masubay man gid nato when mo man yung mga current nga mag-flow, IC. Masubay nato when sila mag-start og conduct, no? So in this case, when VTH nag-start og conduct si IC when VTH is reached in the same way nga mala siyag MOSFET. So pareha. So di na ta mag in detail gid kaayo ani. Pareha siya sa previous. So these are the IGBT applications. It is used in inverters, inverters and converters. So single phase inverter. Inverter is DC to AC. Yeah, DC to AC ni siya. Kani converter DC to DC DC to DC man dapat ang converter. AC to AC siguro yung ikon dire, no? Kani nga example. AC man eh. AC po dire. So converter, unified power quality conditioner. So dili nato makita, ma-observe kung asa magamit ang IGBTs. So mga converters and inverters. No? So how to analyze these circuits? Puan-puan pa na siya pag dito nagita sa actual topic sa converters. Right now, please kabalota kung asa makita ang mga each power electronic devices. So lastly, before we end, when will we use each device? When will we use a BJT? When will we use FET or MOSFET? Or when will we use an IGBT? Based on before we go further, what can you observe? Kinsay mas versatile gamiton? Could you understand the graph just by looking at it? Kinsay mas versatile gamiton? BJT. Okay, si Carl BJT. Who else is an answer? Why man, Carl, nakaingon ka nga mas versatile si BJT? Okay, low power output. Okay. Pero kung ano ba ni siya nga graph, malag ratings ni siya, no? Current and voltage rating ni siya, dili ni siya consumption rating. Meaning, it is the voltage and current carrying capabilities of the device. MOSFET kay kung switching as compared to the BJT, no, mas pa mag-isip MOSFET. So I hope it's apparent, no, or obvious sa ato nga based on yung graph, mas versatile si IGBT. No, mas dako iyahang range of voltages and currents. For example, kanina lang, actually, there's no correct answer, man. No, there's no correct answer. Depende magid sa application nato. Okay, it might be we want an IGBT pero wala available MOSFET lang, so di ba? Pero here, mas versatile actually sa kanilang graph, and I hope this graph actually accurately depicts all the kinds of BJTs, MOSFETs, and IGBTs. But for example, this one. Gusto ta og Okay, that's the ganchag working conditions. Okay. Pero i-compare na to kang sige, i-compare natin si MOSFET. Siguro mas dagan si MOSFET kay mas dagan siyang mga horizontal lines, no? Might be. But mas dagan siya so ito yung gigamit ka term. Click. Working conditions. Okay, mas dagan siya working conditions. Okay, mas dagan siya options. Yeah, it might be. But again there's no correct answer man gid to this one. Depende gid actually sa atong intended nga application. So just for comparison's sake, what if ang atong application is 3,000 volts, no? Ang atong we need control device, no? Switching devices that could handle 3,000 kilovolts. So, dire, mamani ang line sa 3,000 kilovolts. Nala. So, si BJT, dili pwede, no? Dili pa lang daan, si BJT dili pwede. Kay, siguro naras sa mga at most 2,500 ang iyang current, voltage rating. So, X na si BJT. Si MOSFET, if we want to use a MOSFET, kay, let's say, for example, yes, mas faster siya. Tingnan na to, practically, compare na to ang mga specs, no? Mas paspas gid gihapon ang switching ni MOSFET compared kang IGBT. But if ang application is 3 kilovolts, and we want to use a MOSFET, restricted ta na below 100 amps lang ang iyahang kuan o nalasiguro sa mga 40 amps iyahang current rating. Whereas kay IGBT, if we want to use a 3,000 volts, pwede ta mo gamit as low as 100, no? As low as 100 amperes nga current rating or as high as 500 ampere nga current rating. Ganda. Pero if dili factor ang current rating, no, dako lang siya og voltage requirement pero gagmay lang ang currents ang kinahanglan, mas better siguro si MOSFET. Now, if relatively low power atong kinahanglan, no, let's say for example 500 volts lang max. So natay tulo ka choices kay kita nato today mag-apas pa man si BJT. No? Si BJT is naman siya 500 volts gihapon. No? BJT. Remember nga, ang rating is maximum current capacity niya. Ha? So meaning, if si IGBT na siya current capacity nga 900, pwede gapon na siya makakarga 500. No? 900 lang ang max. So here, if atong requirement is 500 volts only, so if atong requirement is 500 volts, so we have three choices. We could use ABJT nga na ay maximum current rating nga 50 amperes, maybe. Or si MOSFET nga na ay mga 200. Or si IGBT nga na ay mga 900. Pero if ang atong requirement, for example, 500 volts and 40 amps lang, example lang, no? 500 volts of 40 amps, again, any of the three will do. Pero remember or let us remember na mas mahal gyapon ning IGBT or si MOSFET kaysa kay BJT. So if factor ang cost, mas better magamit ang BJT gyapon. No? Mas cheaper man gid ang BJT compared to the others. Kay sayang man gyapon gamit tag MOSFET. MOSFET nga 500 volts. No? Nga naay current rating nga 200, pero dili gyapon magamit ang excess nga 200 kay 40 volts 40 amps man atong application. Diba? So I hope you get my point na in practice, no? In practice, depende gid sa application. Pero if wala tay choice, example, gusto kitag high voltage rating, di na pwede si MOSFET. IGBT kita. Here. Ilagay mo light. IGBT ta kung very high voltage application. Pero nalagay po na trade-off, no? Even if ang atong IGBT is makahandle og 550 volts, 5,500 volts, I mean, gamay ra po iyang current rating. Nala sa mga 100 amperes. So, mas asa man doon nga device, no? Kita mo na ito dire. Mas asa nga device, whether IGBT or MOSFET or BJT, if high ang current, low ang yung voltage rating, and vice versa, if ubos ang current rating, dako yung voltage rating. So inversely proportional ang current rating and voltage rating. Siguro katong mga passive electrical devices like transformers mo, siguro itong makakaya o directly proportional na mga kuan, na mga current or voltage ratings. Okay, so this ends our topic on MOSFETs and IGBTs. Any questions so far? For the most part, sabta naman ka based sa mga visuals na itong i-present this afternoon. Diba? Kabalo naman tadaan how MOSFETs work. Kabalo naman tadaan how BJTs work, even katong sa electronics 1 electronics 2. Mga lagi gyapon, no? Nadungagan lang og fact nga factor na this time ang transition, no? From on to off. Before din ato na ginamind ang kuan ato naman is mga gain, ug mga current, ug mga voltage para mapaproperly bias ang transistor, no? So part na siya sa analysis. But when we go to power electronics, not only are those parameters important, but also the concepts or the concept or the fact na transitions will cause our electronic devices to dissipate current. So, mo naman ginatong objective dili for our switching power electronic devices to have quick, no, or narrow transition times. Yan lang, no? As a reminder again, efficiency gid ang atong main objective, no? Efficiency. Ang main objective sa power electronics is efficiency. Recently na ganito'y back converters nga reach og 95% efficient, no? Ako nakita ng back converter lately, 95% efficient. So, kung kaya no? Tsada na siya nga performance. Meaning only 5% lang sa total power ang iyang na-consume. Whereas normal na BJT, no? Siguro ang mga BJTs magidi ay in general mas dako gid sila og mas ubos og efficiency, I mean. So when we come back from our break next week, we'd be dealing with another set of power electronic devices. And these devices, mas paspas pag ilahan ko mas well suited sila for switching applications. And we call those thyristors. pinaslay capability na wala sa either BJT, MOSFET, or IGBT. And this ability is very important, no? Very crucial in switching. So, whatever is the limitation sa BJT, sa MOSFET, o sa IGBT, they could be handled by thyristors. So, na siya itong topic after midterm. So, before we take a break, any more questions? Concerns? So, muna na lang coverage sa atong guys, sa atong midterm, no? Tanan manggawas na sa sa slides. If gusto mo additional information, pwede naman gato mag ito sa internet or sa Google. Pero okay, I believe our slides will be enough, no, para inyong sadihan for our con. Naman to ibang slides, no, kinahanglan gid mo mag-refer sa video kay sulat man ta. So yeah, slides together with the videos para ma-prepare mo sa midterm. Okay? Any more concerns? Are you still awake over there?
Wait pa, sir.
Wait pa? Kain lang. Sige. If wala na concern, we could take a break for the next 10 minutes. We'll be back sa next room by 3:05, no, for logic circuits. Sige, dismiss sa taron. Break sa break. Bye-bye.
Bye, sir.
Bye-bye.